Hello. All right. So this is really exciting because I love being on a panel where I'm the only guy. So this is cool. All right. So I'm gonna do. So my T-shirt says "Honest No BS." I host a podcast called Catalog and Cocktails, the Honest No BS Data Podcast, because life's too short for bullshit. So we're going to have this panel about the future of ML and AI and all that stuff. And actually, we want the audience to make sure to call BS if anything BS comes up. So, well, let's kick it off. I wanted to future of ML and AI and everything. So, honest, no BS. What is the future? Do we just need more data and more compute and more data and more compute? Is that the future? Or is there something else that we need to be focusing on? Somebody go.
I can try. Well, it's interesting to see the evolution of compute systems that we have, right? And one of the things a lot of people don't think about is actually quantum computing. So if you go back to the basics of what it means to actually compute and move bits from side to side, you need gates, you need all these operations, you need electricity. And actually, quantum computing is in an interesting space now that some of the operators and some of the gates are actually available, and we can use it. We haven't yet completed everything that we need in order to have a fully functional computer and processing, but it's making strides. So perhaps that could be the future at some point.
I have to say, I was not expecting that as a first answer. So, quantum computing. Yeah, we'll get to Jeanette. I'm just curious of the audience. So, raise your hand if you've been thinking about quantum computing as being kind of future. Oh, look at that. Okay, cool.
Go invest in the right companies. Maybe the next NVIDIA stock is there.
Yeah. Suneeta, your chip or?
Yep. So. I guess it's a very multi-layered question. When we talk about future, we have to look in from the context of what do we mean by future. If we are talking from an application viewpoint, while Gen AI is doing a lot of heavy lifting, solving a lot of the problem, it has problems as we all are encountering. So what do we do there is one part, but in a real sense, the success of machine learning solutions is really kind of comes to life because of the intersection of bringing high-quality curated data set, large-scale compute, quantum computing is a good part of it as well, plus a very interesting algorithm. So what is the future of machine learning is a complex system where all these stories come together to solve a real-world problem. That's definitely the next first future. From there onwards, what does the long-term future look like? I have a very different vision here. If you go back in the history and we look at the amount of problems that we have solved and amount of problems that we have created, we definitely are creating certain type of problems for ourselves, like psychological problem, mental health problem, and also how we are changing how we perceive things and how we respond to things that we build around it. And we are definitely going through a bit of an evolution to understand how to reframe our mind to adapt to these stochastic systems and not go by very fixed deterministic system. And I think there is something here that would come in future. I'm not sure if that would be AI or a different solution, but there is something here that would come in future to solve this niche problem of how do we actually adopt this stochastic system in our world as a natural entity in a way that's adaptable to us as an adult, but also to younger audience, kids who don't really understand the differences on hallucinated outputs or imagined output that's not necessarily true. For them, everything is true. So it's a multidimensional, but I guess scale is not the answer. There is different aspect of it here, and that all sits around the intersection of technologies, tools, but also human as I guess different entities as well.
Chip?
Yeah, I think this is like a very broad question because I think the future of AI depends, like there are different layers to it, like what Suneeta said. So I think one layer is the base capabilities of AI, right? How much more powerful do you think the models gonna get you? So today, I think, did you see the recent comment by Terence Tao on O1 model? So Terence Tao is a Fields medalist. He's considered one of the smartest humans ever lived, right? And he was like, he compared O1 to the experience of talking to O1 to the experience of like advising a mediocre but not completely useless graduate student. So I think like we were in that phase, right? I felt like we've gone a long way. And there's an Anthropic co-founder, what is this guy's name? Dario. And he was saying like if we keep increasing if the scale laws is true, right? Like we can get a model that's like as intelligent as a Nobel Prize winner. So I think like there's a base capabilities of AI we're still discovering. So not sure how smart they are. So another layer is like what applications can you build on top of this very amazing capabilities. So I do think that we are discovering more and more use cases, and as AI become more powerful, we get more use cases as well. And then the last layer is like, okay, given all these amazing capabilities and applications, how will that change society? How will that impact us, like in our daily life? Like what jobs will go outdated, and like what kind of new job opportunities will become available? So I feel like there's so many different layers to this.
So let's dive into this notion of scale. We were before talking about this. Is like, what do we even mean by scale? And I like what you just said, which is like, we're just now discovering what is possible because we're scaling and trying more and more. So do we continue to invest more in scale and scale and scale? Or do we need to, or where else should we be investing in things, right? We're talking about how do we deal with these psychological problems? Like we're generating stuff that we don't know. And so are we talking about we need to have more on the facts and on the symbols that we were talking about? So how do we balance this investment? And is the pendulum all on scale and then it's going to swing somewhere else, or where is the balance going to be?
I guess scale is, as a scaling law always holds true. We can keep throwing more stuff at it and we will keep getting some improvements, but that's not the true measure because there is also an equation of ROI, and that's probably more relevant that we have to look into the context. If we are throwing all our resources into getting like 0.001% improvement, is that really worth it? I'm not so sure about it. So that's probably the contextualization of the scaling law. But to the other part of it, where does the pendulum swing? Where do we go from here? I again think it's multidimensional. Like many problems in the world today can be solved not necessarily by scale. Like this is going back to the same problem too. Do you really use a logic problem solving with an LLM? It's a good scientific research to say that we are solving logic problem with an LLM to say, can LLM do it? But in a real world, would we do that? I'm not too sure about it. Sure, in a practical sense, it doesn't make sense. And that's why there is a utility of a small, capable model, purpose-built model to be solving that problem, who are really expert and specialized in solving specific problem. But then also there is a very good importance of a high-level orchestrator model, like like if you go back to Jan LeCun's thinking about what is the world model, the thinking is that there is a system of experts that drive and solve the problem, and not every expert needs to be at scale. Some experts are really very smart, smart, but they are able to do a very narrow task. But then there are a higher-level planning system that sort of can do a high-level planning, doesn't know everything about specialization, but can do a high-level planning and can build the whole thing together. And it's biological inspiration, really. Like even if you look around, there is GP who looks at general practicing, doesn't necessarily know specifics about radiology, but can high-level say, now you need to go and talk to radiologists, right? But then what radiologist can do is not necessarily done by GP. And that system is kind of being modeled now currently with this agentic way of solving problem. And that's definitely what we have currently to solve some of the future problem on planning, execution, realization where do we go from there? I don't necessarily believe that LLM is the solution because of very like a long-term solution. And I would love to see the research come through to see where that would go. But yeah,
Well,
I think scale, I'll just continue what you said. It was brilliant. Thank you. I think scale is an interesting question because most of us are not going to train our own models. We're going to take something that exists. We're going to either fine-tune it, add some data, ground it in context so it will stop hallucinating through things like RAG. Hopefully stop hallucinating. I don't know. Many things can happen too. Many bad things happens to good data and good machine learning systems. But scale is really interesting because most of us are not going to train our own machine learning models. We're going to take things that are built in. We're going to take either a small model and a big model and leverage them together to produce that specific expert that we need, or we're going to take only small models. We're going to pour RAG into it or something like that. We're going to prompt it. And I think scale here has another angle of where do we deploy it? Do we deploy it and use it everywhere and anywhere, or are we becoming more specific? Because it feels like, I'm just going to throw it on the wall and hope that something will catch at some point. We see it a lot in the industry. It's like, hey, maybe now I can do LLMs for anomaly detection, something that used to be solved with very specific statistics and mathematical algorithms. But how about this large language model? I can ask that, was there any anomaly in that data that you can detect? And then it's a question of, can it actually run that mathematics, or is it an overhead? Should I use it for this problem? So this is how, at least, I see scale. I wonder, Chip, where do you see it fit? What scale is for you?
Yeah, I think scale has many different meanings. So as you mentioned, it's like you can scale one use case to more users, or you can scale up like multiple use cases. But I assume you're talking about model scaling, as in I think from the AI perspective, we see that if we're just throwing more compute and more data at models, it's getting smarter, right? And the question is how far along can we keep on doing it? What's the threshold? When we max out? And I think that's so just talking to a few people recently, Anthropic and OpenAI people, and it's very interesting. So they realize it's a while ago, a few years ago, they realized if they just keep training bigger models with more data, and usually data costs money, but historically it doesn't cost nearly as much as compute. So people index scale based on compute, right? So for example, they say okay, every time you 4x the amount of compute you use for model, you can notice a difference in the model performance. And why 4x? Because okay, if you double it, it don't really show clearly difference. If you but 4x is a minimal amount of scaling up for you can see the next generation of model, and then people don't immediately release this 4x. So the question is just what are the bottleneck to this? So you can the number of parameters you can just increase it arbitrarily, right? So I think compute actually an easy solutions. I think maybe last year, 2 years ago, everyone was freaking out there was not enough compute. But I think we're at the point when compute is actually not the issue. So what are the bottlenecks? So I think two things. One is the data, right? We actually at a point where we actually run out of internet data. We are pretty close to it. And the question is where do we get the next more data to train this model? And the other electricity, because compute actually consume a lot of electricity. So right now, data center around the world consume about I think different estimate, but about 1 to 4% of the world electricity. So that means we can increase by 20 or 50 times. So which less than 2 orders of magnitude, which is not a ton. So we either have to come up with new electricity source, or we have to come up with more efficient compute engines, like quantum computers.
So my takeaway, I'm here taking notes here, is when we talk about scale, I think the question on purposely was a bit ambiguous to see where we would go. And we talk about compute, about data, about people, about use cases. And also I want to dive more into the use cases, because I think depending on the use cases, you can say, do I need more data? Do I need more people? Do I need more compute for this? So what are the use cases that we're seeing today where we're hitting the limits, but with more scale of something, we're actually going to get more, better, different, powerful use cases? So in other words, what are the use cases of today that we say, oh, this really should be looking like this tomorrow?
I'm actually a little bit afraid to say that because it's always like the biggest fear. But I think software development, we're seeing Copilot, we're seeing Cursor, we're seeing a bunch of tools that actually produce solid, code. It's not too complicated. It doesn't solve any too complicated logic. It's not super smart, but hey, it works well, and it's better than, a student that just came out of college. So when we think about that, there's a lot of opportunities there when leveraging LLMs and technologies like that, and that's, to be honest, scary for someone who works as in that space, right? We're being paid for producing code, and now I'll have this machine that costs $10 a month to replace me, and so what my future will look like, right? Now I need to become more sophisticated. How do I do that?
Suneeta or Chip?
So I think it's in my opinion, I think it's the language. It's so complicated, and even when we scrape the data, there is inherent bias in the kind of data that is and the kind of way it's phrased, like the way of saying. Even today's model, Anthropic, Google, GPT-4, we try and we can see asking the same question in many different ways, we can get very different answers, from absolutely wrong to absolutely correct and somewhere in between. And the reason for that is that although we think the model has learned the language understanding and can map to the right knowledge space, it hasn't, because the human, the natural language is so deep that we cannot really represent that even with the internet data. But also training with the internet data is just so limited because there is so much of redundancy from language translation, redundancy from duplication. So how do we extract all that and create this really nice, rich data set that's representative of this meaning said in a different phrases, so it can actually understand what, at least as a human, what we are meaning to say. We are not quite there yet, but we have literally scraped the entire internet to model that, right? So I'm not sure if LLMs are capable to do that, but I think they are definitely capable to model that to a greater extent to be able to be useful. But to answer your question, to how much more data scale, what problem can be solved, I still don't think that we have crossed that bridge of properly modeling language and to be able to solve programming in English. We are not quite there yet. And all these workarounds, self-consistency, things like these inference optimizations, memory and all these techniques are just a bit of a workaround to solve the inherent problem that the language understanding is not quite successfully modeled in a natural way as a human brain or a biological intelligence can do today.
Urino.
So I think that I like what both you said about different use cases that AI can enable in the future. So I think of them as how easy it is for something for AI to do something depends on two factors, right? One is just how complex the task is, and we see that AI can actually do quite well with a lot of simple tasks. And when you talk about complexity, we usually have human bias as humans, right? We look at things and we think, okay, is that complex for me to do? That must be complex for AI to do, but that's not true. A lot of things that's very difficult for us, but extremely easy for AI, and that's why historically as humans we keep underestimate or overestimate certain capabilities of AI because okay, for example, humor. Humor seems it seems straightforward, for a lot of people to do, but it's actually really hard for AI to come up with original jokes that nobody has ever told before. Or another aspect as in complexity is about how much factual consistency that you need the model to do. So for a lot of tasks that doesn't need a lot of like factual consistency, AI is killing it. Like all this like AI companion, digital girlfriend, boyfriend, right? Like a lot of creative tasks. Because creative tasks, you just need it to come up with something that's like very fun and interesting. Like if you ask it to generate a picture, right? It doesn't have to be factually like accurate. It just needs to like look nice, artwork, pretty, or like capture the essence of the query. So like AI is definitely killing at it. Like copywriting, AI is like really good at SEO because it trained on a lot of internet data. And the way internet data works is funny because like if something is good at like SEO, it would be like surfaced a lot online. And a lot will copy it. And like SEO optimized data is like very, very abundant on the internet. And the models trained on this data get really, really good at like generating like SEO, like very optimized content. So we see a lot of like content farmers. Have you come across like really AI generated content like just to make money? So I saw recently a new kind of scam. I thought it was very smart. I wouldn't do it myself, but I thought it was a very interesting idea. It's that people that generate fake travel guides. Because like just like copy, like just make up like, if you've never been to a country before, right, you don't know if this address exists or like this restaurant exists. So you just need to generate things that look like travel guides, and then they can like use AI to generate reviews, AI to generate website, like write SEO to promote it. It's just like full-fledged like operations. It's quite crazy. So I think like for that kind of use cases, like AI is like really good. But like if you want something that's like really, really accurate, we don't quite understand why model hallucinate or like how to reduce hallucinations. Like a lot of time we say that's like, I feel like I can go into like a lot of details on hallucinations, but maybe it's a different discussion.
Let's dive into that because I think that's kind of a topic. That's where RAG comes in and stuff. And I mean, whoever came to my talk before lunch, right? I'm all about knowledge graphs as a way to be able to go deal with these hallucinations and accuracy and stuff. So one thing I really like what you just said and got me thinking is, if we were to separate simple tasks and complex tasks, I mean, we always think, oh, this task is complex, it must be hard also for the machine, right? And if it's simple, it must be simple for the machine, but not necessarily, right? I think what we should be thinking about is like, maybe this complex task is easier, and maybe the simple task is harder for the machine. But then one thing that we are kind of acknowledging right now is that accuracy, especially now with generative AI, that is a hard thing. So what is the future of that? Do we think we're going to achieve places where we're going to get better accuracy? Or will we enter a future where we like, these are the use cases where accuracy, for these use cases, accuracy is not important. Great, it's killing it. And for these use cases where accuracy is crucial, AI is not going to be there. Or I wonder what is the bridge here? Like my answer to that is like invest in knowledge graphs and semantics and stuff like that. But I'm not the panelist, so I'll shut up.
Yeah, I guess some of the challenges is, like Chip said, we're generating new data and this data becomes facts. So now these new fun travel guides are now creating a new fact of existing, existing attractions or existing streets, right? So now we have new streets in whatever country where these streets didn't exist before. So if we take that data and feed it back to the model, these are now the new facts, and we just continue to iterate on top of these false facts from the get-go. So what we do usually is we actually bring in people into the mix to label that data, go over the data, make sure the data is good to go, is accurate. And you will see a lot of organizations that are building chatbot applications or Q&A applications. What they do, they'll take everyone in the company and they will bring in all the information about their product and everything that they need into kind of like a file or format or type of data so they can later on feed it and fine-tune an existing model, so that model are now trained on real data that was curated from the company. Or they will take books that are known as very good, as fact-checked, and went through a review process with real humans, and they will feed that into the system. So there is a way for us to go and actually make sure that the data is accurate, of high quality, and by just leveraging people that can feed the data and tell it, hey, it's good or it's not good. Better paid people than not paid people, just for security's sake. Who are the people that you're bringing in, they have the right incentives. And yeah, they're building it today.
That does open up the question of scale of people, right?
Yes, but there's also a question about, just enough data that is high quality versus a lot of data that is data swamp.
How are we going to address accuracy, or we're not going to address it?
So I think this like should debug, right? We first need to understand like what causes this bug so we can fix it. So I think like we still need to understand like what causes hallucinations for model. So like one you say like just like because of internet data, low quality, a lot of like misinformations, agenda, whatever, right? So I think like that can be partially addressed by like companies just being more thoughtful about the data curation process. So I actually really enjoyed reading the papers by model providers. For example, like the Llama 3 papers. Like it's really good when they talk about like how they filter out data sources using both AI and heuristic. So that data problem. Another is that could be from the post-training. Like, are you familiar with ILHF? Like reinforcement learning from human preference? Yeah, so the post-training, so like a model is only trained on two phases. Like pre-training is like when you just give it a lot of like data, a lot of text data, like internet data, and you train it to predict the next token. So you can think of this phase as like trying to train the model to read the entire internet, like acquire as much knowledge as possible. But of course, internet is like a cesspool, like whatever, right? Like, what it learned from internet may not be accessible or like might not behave in the way that you want it to do. So you have to train it from the post-training phase, so the human preference, when it shows it really high quality instructions and responses, to try to like activate it like in a way that we want it to react. So in that phase, now it's a tricky question, right? Now we have like human labelers, like so they're very smart people. If you look at like this company, who they hire to be the data labelers, like they're very smart. They are not like people we can hire for like 2 cents a response. Like they are like actually smart people. And I do think that like if you want the AI to be smart, you just need really smart people writing smart responses. And now we have all these human labelers who have knowledge that we don't know about, right? Like you, like as a human, you know things that your friends might not know or like other people might not know. So now you have this human using the internal knowledge to like write responses. And now the AI does not have access to the model, like to the human knowledge, and just sees the responses. So if we try to teach the AI to like copy the response from the human without knowing this human knowledge, we are basically teaching AI to like making up things, because AI does not have the understanding of how this human come up with this answer. So people are trying to fix that by like trying to like have the labelers like explain their reasoning. Like here's a step. We probably heard of the thing like chain of thought reasoning, right? So trying to explain like here's the sources I use and here's this, and like so that's why I come with it. So like some of this can also be like solved by the post training, like human preference training. And then the usage case, so like there have been a lot of research done on like when models are more likely to hallucinate. So like people have found out like in many papers, it's like models are more likely to hallucinate when information is more niche and unlikely to like appear in the data. So that's an example, right? Sorry, I feel like you should cut me off. So I do think this like, I think of factually consistency. So you think about it, it's like, what does it have to be factual consistent with respect to? So like sometimes like if you provide with the context, right? Usually it's just to compare the response with the fact, and if it is deviate, then it's like inconsistent. But the hard part is not that. The hard part is for the model to decide like what is considered fact. And I think there's research done on like what AI tend to lean toward is very different what humans lean toward. Like first of all, if we read papers and we think, okay, we see that is the citations like valid, is this like good sources? Actually, people have done research and they found out that like AI actually rely on different signals. They're not quite the same as humans relying on the signals. But anyway, I think it's like...
No, this is interesting. And I think one thing that we hear a lot about kind of dealing with this inaccuracies and hallucination stuff is RAG, which we talked about a bit, retrieval augmented generation. A few weeks ago, I was at KDD and I was at Meta organized a workshop on RAG at a benchmark, and I was there giving a keynote, and so was Patrick Lewis, who was the first author of the RAG paper that came out. So here are some notes that I had. we were talking about the future of RAG. I mean, he was on the team who did RAG, right? So he says 4 years ago, the goal was to be able to get an accurate answer for how many calories does an apple have. And he says, like, today, we can actually retrieve documents for a web, do an analysis, create charts. So it's really amazing how much we've advanced in RAG from like 4 years ago. So he thinks, like, today, if long-tail knowledge is in the pre-trained data, it can be found. Retrieval from the web makes it easier to deal with updated information. But the challenges still persist are the whole black box and the explainability of these models, and also dealing within the private domains. So, kind of question here is, like, how do we see the kind of the future of RAG, and how is that fitting into with the accuracy? And just my quick opinion here is that I feel sometimes RAG is kind of a hack. And is it a hack, or is this becoming a robust solution or a robust approach?
Yeah, it's a little bit of both. So last week I was at Corinth. This is the biggest data streaming event in the world. More than 4,000 people coming in, flying to Austin. There's also one in London. There's also one in Bangalore. And one of the main topics that we discussed was agentic RAG. Agentic is the new agents that we're all talking about, how we can take a model and we can give it a prompt to become something more specific, or we can fine-tune it to become something more specific and answer a very niche area and fix a very specific problem that we wanted to fix. And then RAG comes in because we want to ground the context that we're getting. We want to ground the question in real information that we can stream into our system in real time and have it fact-checked and have it all the data quality the rules that we want around it. And we actually build a system that shows, because of kind of like a workshop that we did, kind of build a system that shows you how you can create all these agents and how you can leverage the new Flink AI capability that's available in the open source to kind of call these models and leverage the real-time data that streams inside your system to call the different models in the sequential order that you want, or ask it for a dedicated sequence of how to call every model, giving how you prompt the model to be expert on to start with. And that gave a really, really good results because the context, everything was grounded. So it wasn't only a query that came in. We actually connected it to MongoDB, and through MongoDB, we pulled more information that we needed in order to ground the context and enrich that prompt that we sent to the models. And this actually really helps us with the hallucination fact, because, for example, if I'm taking an application that tracks my flights, for example, and I'm chatting with an assistant, a potential, probably an AI-based assistant, AI-based chatbot, I want to get answers that I tailored for me, right? I want to know where my flight is, it's not going to be delayed or anything happens. I don't want to get any generic answers. I want to know what are my options right now. And behind the scenes, there's a bunch of AI stuff that runs. It pulls in the right information through RAG from their own database that's available there. They enrich it, right? They ground the context. And they give me a response that it's tailored for me. Now, security-wise, right? Because one of the biggest challenges that we have with the big models is we're actually sending data to an external entity, and that external entity is going to take that data, digest it, and it's actually retraining on top of this data, which means it might be that if I'm giving it private data, it's going to spit it out to some other customers. And this is a big problem in the space that we operate in, and then there are 3 questions that we need to ask. One, are we using these models in order to process some customer information that we're not allowed to expose? 2, are we using this model internally for our own benefits, for example, writing better code, right? And 3, are we want to use this model, we want to train these models internally because we have things that we were not willing to expose, and then there are existing models today, but we will have to host them and go through all this process again and again. Or are we want to use just external models without giving it that information? So I can share, I work at Confluent, and one of the things we build something called Halfluent. And Halfluent is our own in-house ChatGPT. We have very strict security. We're not allowing anyone to use ChatGPT or Copilot or any of these tools. And in-house, we only use Halfluent. And Halfluent is our own model that we're hosting, our own model that has access and allowed to go to our data and goes to our security channels, and no one outside of the company can use it. And also there's limitations on what the context that it maintains, because we're hosting it, it's within our infrastructure, everything is ours, nothing gets out. So to your question, to the level of security, yes, it's super hard, but it's critical, and companies are doing it, and we're not the first one, and we're definitely not the last one to do it.
Any other thoughts on RAG? Or
I definitely sit on the camp where I think RAG is more a workaround or a fix than a solution. Definitely helpful, but not a solution, more a fix. I think that your question has two parts to it too. How do we measure success, and how do we build for correct use cases? And I think where it becomes really hard to design an accurate system is when we are trying to build something so generalist that can do everything, but also want to be accurate at the same time. We can if we focus on a particular problem, this is again going back to specialist, generalist piece, if we can focus on a specific space, then we can go really far and be more accurate, because I think you alluded on knowledge graph. There's a lot in knowledge graph that represents this domain constraint. These things are related to each other in this fashion. And we can use that domain knowledge and enforce that and make sure that the model is more accustomed to it or conforming to that knowledge represented in that domain graph. That's a lot more easier done in a constrained environment because you can build that knowledge graph. But there's no such knowledge graph for the world, right? There's so complex. It's practically impossible, but it's possible to do that for a specific domain. And that's why it's easier to build more accurate system in a specific use cases. So I think the world is definitely there where when we want higher accuracy and realistic use cases, we go towards that specific implementation, but wire them together with a system that looks a bit more holistic. But also I think there is a piece here about mindset. To your point, if the system is not so accurate, do we not just build it? I work at Harrison. We build medical devices for radiologists and pathologists. They are stochastic system. They are not 100% accurate because they are stochastic, but so are humans, right? So are radiologists and pathologists. They are not 100% accurate because this is really hard problem to solve. These guys learn in that domain for 20 years, and they accepted that it's so hard that they cannot make that decision. And there's clinical trials and clinical studies have been conducted that shows that if they use our product along with their own knowledge, that they are 45 to 50% more accurate than they would have otherwise been. So here is a realistic example that's practically I'm speaking to because my team builds it, and these products are really useful even though they are not 100% accurate. And the way they are helpful is because they come in with this mindset. The people are informed that these systems are not 100% accurate. These are the ways to use it. These are the guidelines where you need to pay extra attention to, but make your own choices. And there's this notion of building this muscle of how do I use this system that's not 100% accurate, and that ecosystem around it. But I certainly take your point that there is a big value in enforcing that domain constraint in building that system.
So I want to hit one more topic. We got 10 minutes, and hopefully get time for one question or something. But to wrap up, last topic is on the evaluation. And we've been talking about accuracy, and that's a part of measurements. And you early on, Suneeta, you were talking about we're moving into this very stochastic and non-deterministic world. How do we think about evaluations around these things? How do we think this is correct? This is getting better. How do we measure this? I mean, talk about the future of machine learning. Before everything was precision and recall, right? F measures and stuff. What are What are the new types of measurements that we have to go do? And we talked about scale or so many things, and we had to scale with people. How does the world look like tomorrow when we're evaluating? And that will be our closing topic before hopefully we have time for a question. But who wants to go first?
Let Chip start.
Yeah, I think evaluation is a very important topic. I do think evaluation is the biggest challenge to like deploying a lot of AI applications. So I think it's like we are switching from more like closed-ended tasks like classification to more open-ended, like the model can generate anything. So I do think it's like there are many challenges, but like two key things is like one, as model getting smarter, it's really harder to evaluate it. And the reason is that like almost anyone can say whether a first grader math solution is wrong, but very few people can tell whether like a PhD level math solution is wrong. So like it's just getting harder and harder to evaluate models. And second, with open-ended evaluations, you don't really have ground truth to compare it to, because it can be anything, right? Like say if you ask a model to generate a book summary. So if the summary reads coherent and reasonable, right, you don't really know if it's a good summary or not until you can actually read the whole book and tell whether the summary is like makes sense. So it's just like extremely difficult. And I've been recently using the terms that I call like evaluation-driven development. So it comes from software engineering, like test-driven development. So the idea is that like even though a lot of people try to build applications for fun, for FOMO, fear of missing out, most business decisions are still driven by like whether I can get good return investment or not. So that means that they would only deploy applications that they can measure like outcome, evaluate outcome. So it's not coincidence that one of the most popular use cases we see today are like use case with very clear measurement. So for example, recommender systems. So you can tell whether a recommender system is working by just like, okay, like is this increasing engagement, purchase through rate? Like fraud detection is very clearly measurable. Like is the fraud rate decreasing? Are we paying less money? Are we losing less money? And coding. Like coding is actually like our own open-ended generations. Coding is something you can actually like try to evaluate by like functional correctness. Like you can try to compile the code. Does it compile? Like can it pass on the unit test? So like people are very comfortable, like a lot more comfortable rolling out coding assistant because they can tell whether the suggested code is actually making the code better. Can it solve like the bugs? So I do think that's like So like this approach is good. Like companies deploying applications that can evaluate is good, and it's very sensible. But we are so in situations where we are trying to like search for the lost key under the lamp. We are staying there because we can see the light. So we're sticking with a few use cases because we can trust the evaluations. But we might be missing out on a lot of applications that could be a game changer, but there's no clear way to evaluate yet. So I do think that if we can come up with new ways, like to evaluate models, we can unblock a lot of different use cases.
Yeah, in the traditional machine learning model, what we used to do, we used to take the prediction and we used to take the actual and compare the two and then see the difference. How far are we from the predicted to the actual? And like Chip said today, we don't know what the actual should be, right? We just have whatever the model gave us and we hope the user is content. Or if there's no user at the end to give us any feedback, we're kind of running there blind without knowing if it's good or not. And this is where I think, in academic world is kind of like these grand models that everyone trying to compare their results to these models that are known to be state of the art. But this is, again, an academic. This is people doing it for research, trying to make the model a little bit smaller, a little bit different, a little bit different approach, different architecture, and so on. But it is an open question. It is case-by-case scenario, and it is still a place where we are exploring what could be the opportunity, what could be the next way of evaluating. And then the question is this use case that we are now putting together need a strict evaluation?
Suneeta?
Yes, I think it's a very good question, and I think both of you gave a really good answer to that. What I would add to that is there's two different varieties of evaluation, quantitative and qualitative. Quantitative, if you can build a quantitative evaluation, that's really good because then you can use these numbers and we talked about precision recalls. They are really good to contextualize how good the system is. But as Chip was alluding to, there are whole heaps of problems where you can't really build a quantitative solutions around it. It just what you have got is qualitative metrics, and they're so noisy. There's a human perspective embedded in that qualitative measurements. It's more like how I like that particular book summary may not be what Eddie likes it. She might have a different perspective, and that's why it's so noisy. So the way to measure this, if your domain is where the only way to measure is qualitative, then you've got to bring human in the loop. You have to bring your experts in the loop, let them evaluate, let them give you the feedback to, is the system the where you want it to be. It will never be 100% because even human will not be 100%. But if it's somewhere where it's better than an average human consensus, you're probably solving a lot of the problems. And from what my previous experience has been, it's definitely doable to build a system with bringing humans in the loop to continually iterate and get to a place where the system, together with human, can perform better than a human without that system.
So one of the things I do in the podcast, I always provide the takeaways because this has been a fantastic discussion. So I've been taking notes. I'm going to quickly do takeaways, and I think we'll have time to take probably one or two quick questions, or probably one. But so we kicked off about, hey, the future of ML AI. Is it more data, more compute? Adi said quantum computing is approach, right? I think you're also looking at the short future. So many things need to get connected. There are these new problems we're creating. They're like psychological problems. We need to really refrain our mind for stochastic systems. Chip, I like that you said we're still discovering what is possible through scale. So when we got into the whole discussion, how much scale do we need? Like if we throw resources more scale, but what is the ROI? Was it really worth it? A lot of interesting research to see if LLMs can actually solve logic, but hey, in reality, are we going to use LLMs to solve logic? Probably not. Most of us are not going to train our own models. Where are we going to deploy this? And when we think about scale, we think about compute, data, people, use cases. I mean, we need new electricity sources, but there's different versions of type of scale. For the use cases of the future AI use cases, I mean, co-pilot software development, that's definitely something that's going all around. Understanding the true meaning of language. We are doing workarounds to be able to go do this. There's complex tasks for us, may not necessarily complex for machines. So I think it's interesting to kind of find this balance between what's complex and simple. AI, which doesn't need consistency, AI is killing it. That's what Chip said. I like that. Dealing with accuracy is an interesting theme. That this is a whole machine learning automation stuff, but there's a lot of people discussion we had today, right? Bringing people for labeling, like we can do people. Small quality data can't work at scale. Like RLHF, that's all about having humans in there. And I think it's also, if people consider hallucinations a bug, we really need to understand why that is a bug to figure out how we can improve that. Is RAG? What is the future of RAG? Agentic RAG, right? Make it more specific. Focus on smaller problems. Security is always going to be one of those big issues. RAG can be considered like a workaround. It's not a solution. They're trying to create, I like this, we're trying to create this general solution and then at the same time make it accurate. I think what we're realizing right now is that let's stop considering making it a general, make it more specific, and give us chances to be more accurate around that. And use a domain knowledge in a knowledge graph. And then at the end, evaluations. One of the biggest challenges, we're coming from a closed approach like classification to something more open-ended. Many can say if a first grade math problem is hard, but not many can say if a PhD math problem is wrong. If it's wrong. Summaries, for example, right? How do we do that? You don't even know if that was a correct summary if you've read an entire book. Think about test-driven development. So we really need to think about evaluation, need new ways, and it may be a case-by-case approach. Because comparing the actual to the expected is what we've always done, but we don't even know what the expected is today. And I think there's this whole balance of figure out quantitative versus qualitative evaluations. And at the end of the day, I think one of the themes throughout the whole thing was people, which I'm actually very happy to say.
Yeah, it's very interesting knowing that actually AI is generating more jobs for us, right?
Yeah. Well, that was my summary, and I think, sorry, I took up more of the time with that. This was a fantastic discussion. I learned so much. I got these notes. Thank you all for your time.
Thank you.
Thank you.